Hey everybody, Jay back here at Easy Astronomy, trying to make astronomy just a little easier for everybody. Got three items that came up today that I just thought I wanted to get out and share. So the title of this podcast, we'll call it Hubble and the Chaotic Dracula's Chivito. We're also going to talk about the Topsy Turvey universe. And then finally, the holiday dance of two dwarf galaxies. So we'll begin by going and jumping immediately over to talking about a article called Dracula's Chivito. Hubble reveals the birthplace of planets observed. This is over on physics.org. Basically, what it's doing is the Hubble Space Telescope captured high-resolution images of the protoplanetary disk IRAS 23077 plus 6707, also known as Dracula's Chivito. It's probably the largest protoplanetary disk that we've identified so far, and it reveals a complex structure with substructures, asymmetries, and dynamical activity going on. The key findings in this study include the discovery of a rich tapestry of substructures, brightness asymmetries, and signatures of dynamical activity in the disk, as well as extended filaments and prominent wispy features. They present through the Hubble Space Telescope Wide Field Camera 3 an image of the near-edge-on protoplanetary disk, IRAS 23077 plus 6707, Dracula's Chivito, obtained across 6 broadband filters spanning 0.4 to 1.6 In addition to large-scale asymmetries, the disk exhibits prominent wispy features that extend well above the midplane and are visible in all filters. Features that suggest a complex, possibly turbulent outer disk atmosphere shaped by infall, dynamical stirring, and gravitational instability within that protoplanetary disk. The radiative transfer simulations show that the current data cannot yet distinguish between dust settling and no settling scenarios. They underscore the need for resolved infrared observations to continue for this unique system and to occur. The objective of the study was to unveil the structure of that protoplanetary disk using high-resolution imaging. The methods used in the study include high-resolution imaging using the Hubble Space Telescope Wide Field Camera 3 and radiative transfer simulations. The results of the study show that the disk exhibits a complex structure with substructures, asymmetries, and dynamical activity. They include extended filaments, prominent wispy features. There's just a lot going on. The star that it's around is relatively young, I think about 11 million years if I remember right. And it's interesting because we're seeing the formation of a planetary disk around a young star, and we're going to be able to learn from that both how planetary disks form planets around stars, and also kind of relates then, well, I'll be able to take that knowledge and kind of apply some of that to the formation of our own solar system. The conclusions of the study actually show that IRAS 23077 plus 6707 is a rare and valuable laboratory for studying the vertical structure, asymmetries, and evolutionary state of protoplanetary disks. And it's just really kind of cool to think about it in that way, that what we're actually seeing here is one of the largest birthplaces of planets going on. This protoplanetary disk is about 1,000 light years from Earth and spans about 400 billion miles. It's 40 times the diameter of our own solar system. So basically going out to the outer edge of the Kuiper belt of cometary bodies out there. The disk actually obscures the young star within it. They believe it's either a hot massive star or a binary pair of stars. And the enormous disk is not only the largest known planet-forming disk right now, it's also shaping to be one of the most unusual, which I've talked about. What they're seeing there is rare. They haven't seen that before. We're seeing it basically edge on, And so those wispy upper layers and asymmetrical features are especially striking. Both Hubble and James Webb have glimpsed similar structures in other disks, but this one provides us with just an exceptional perspective, allowing us to trace its substructures in visible light at unprecedented levels of detail. Makes the systems unique, and it's basically a new laboratory for studying, like I said, planet formation in environments where it happens. A lot of wonderful things going on in there. It's an exceptional case for studying the birth of these planetary systems. Okay, the next one coming up, we're going to move on to the next one, Colliquium, the cosmic dipole anomaly. And it was a wonderful paper to go through. I enjoyed going through it and looking at it. So for nearly 100 years, maybe a little bit more than that, we've looked at the night sky and told ourselves a very specific story about it. It's a story about balance. In the world of cosmology, we call it the isotropic principle. It's the idea that if you look far enough into the distance, the universe looks the same in every direction we go. It's smooth, it's predictable, and it follows a very neat set of rules. It's comfortable. It's comforting, too. But what if that story is wrong? What if the universe isn't smooth, isn't uniform? It's not a uniform ocean, it's not uniform across it, but actually it's a little lopsided, a little tipsy-turvy. It's actually tilted. A groundbreaking new study, which I just mentioned, recently highlighted in the Reviews of Modern Physics, suggests that our universe might actually be lopsided. This just isn't a minor detail. It's a potential red ball for the standard model of cosmology. To understand why, we have to look at something called the cosmic dipole. For a long time, astronomers noticed that one side of the sky looked busier or hotter than the other, but they didn't panic. They assumed it was just a perspective trick, that the Earth, our sun, and our entire galaxy are simply drifting through space toward a specific point. It's like looking out the side of a window of a moving car. The world looks different because you are moving, not because the world itself is slanted. However, Professor Sabar Sarkar and his team decided to put that assumption to the test. They just didn't want to look at the light, they looked at matter. They analyzed catalogs of hundreds of thousands of distant galaxies and quasars, and what they found is actually quite startling. The lopsidedness is how matter is distributed doesn't match the lopsidedness of our motion. In fact, it's much more extreme. The data suggests that there's a genuine asymmetry in the fabric of the cosmos. There is more stuff in one direction than there should be. Now, why does that matter to you and me? Because our entire understanding of the universe, including dark energy and the speed at which space is expanding, is built upon the math of a perfectly balanced universe. If the universe is fundamentally lopsided, the equations we've used for decades might be incomplete. It'd be like trying to navigate the globe using a map that assumes the Earth is flat when it's not. We are at a crossroads in science. We have the standard model, which has worked beautifully for years, butting heads with new raw data that says the model is actually broken. As we launch new telescopes like the Euclid and the Vera Rubin Observatory, we're going to get an even clearer picture of what's out there. We might find that we live in a much stranger, much less symmetrical universe than we ever dared to imagine. It's a reminder that in science, even the most settled facts are only as good as the next discovery. Anyway, we're going to post that on our Patreon. You can take a look at it. I'll link it over to the article so you can see it. And we're going to move on to the next item. And the next item was released just a little bit on December 22nd yesterday by the James Webb Telescope site from NASA. It's called A Dance of Galaxies. Thus, I call it a holiday dance of two dwarf galaxies. The two galaxies that they specifically targeted were NGC 4490 and NGC 4485. They're located about 24 million light years away in the constellation of Canis Venatici, the hunting dogs. They're the closest known interacting dwarf galaxies, system where astronomers have observed the interactions between them as well as been able to resolve actual stars within them. James Webb Space Telescope captured the two nearby dwarf galaxies interacting with each other, and they released an image which I'll post on the Patreon site on December 2nd, 2025. The dwarf galaxies can give us insight into galaxies in the early universe which were thought to have less mass than galaxies like the Milky Way, Andromeda, and others around us in the local group, and other galaxies in general right now. They also contain a lot of gas, relatively few stars, and typically have small amount of element heavier than helium. Observing dwarf galaxies merge, they say in this post, can tell us how galaxies billions of years ago might have grown and evolved. That helps us to understand how galaxies have come about in their present form, and just increases our knowledge of the lifespan of galaxies. And so we'll put a link into the Patreon, and you can go to that link and go right to there. Covers everything I just covered, and I hope you find these things interesting. I do. I think it's fascinating. Our universe is fascinating. I hope you have clear skies. I hope that if you find this useful, you consider joining the Patreon site. Membership is free. The info there. You'll get notified by email when I do a post. In addition, if you find it interesting, valuable, or whatever, consider becoming a contributing member. It's $3 a month, not a lot. It just kind of helps to offset some of the time and stuff that I put in. If you don't, that's fine. I'm still going to make everything available and free. There'll be a few things for those who contribute that are probably just a little bit above and beyond than the stuff I post for free, but 98% of my stuff will stay free. I've always done that. If you go to my blog, Jay's Astronomy blog, and I'll continue to do that. But if you find it valuable, consider becoming a contributing member. I would appreciate it. Anyway, have a great evening. Clear skies to you. Talk to you soon.